So hello and welcome again to this new notebook in which we will be exploring the supervisor-researcher delegation architecture for conducting deep research with LangGraph. So what we are building, this implementation uses the hierarchical delegation pattern or researcher pattern, and let's look at the main architecture of our workflow. So it starts with the user making a request that goes into the user clarification node. Here we clarify the request, and next we go to the brief generation node. Here what we are doing is generating a detailed and focused brief that will guide the behavior of the research supervisor. So the research supervisor can use its thinking tool to make a detailed plan and then use the conduct research tool to spawn one or more sub-agents that will be working in parallel to gather the findings. What is important to know is that these findings are compressed before passing them to the research supervisor. So once the maximum number of iterations has been reached or there are no more to cause, we can finalize this phase and go to writing the final report. So let's look at the node. Here we are setting up the API keys. As we said for the search, we are using Tavily search. The state structure is hierarchical with three levels. We have the agent state, the supervisor state, and the researcher state. And to understand this better, let's look at these workflows. The agent state is in charge of the main workflow. In the main workflow, we have the research supervisor node that is in turn another subgraph. And the supervisor state is going to be in charge of this subgraph. So here in this workflow, the supervisor will use the supervisor tools that will spawn, as we have said, different researchers, and each researcher will have its own research state. And what do we need to do this to have three different states and not one huge state? Because we want separation of concerns and avoiding what is called as context rot. So let's continue with the notebook. Here we have the utility functions and tools. We will be using, as we have said, Tavily search for searching and the thinking tool. And these tools can be found in the utils.py file. And what is interesting about the Tavily search is that it has summarization. So it summarizes the search results from Tavily search API. And next, another thing that is also interesting is the thinking tool. Here we have it that allows for strategic reflection. So let's continue. Here we are importing our tools. And let's go to the configuration of the system. So this configuration, we have it in the configuration.py file. And what we want with the configuration is to have a flexible system. So we can tweak or swap research behaviors, the model configuration, and the search configuration. For example, we can allow clarification or not, the first step of our main workflow, how many concurrent researcher we want, or which will be our research model. Is it going to be Gemini? Is it going to be OpenAI? Is it going to be Claude? So here, what we are doing is to import the configuration and the search API. Next, let's go with the prompt templates. This is also really interesting as we have here in the prompts.py file lots of templates that will shape the behavior of our models. What is important to know about these prompts is that they are specifically curated to avoid common failure modes of this multi-agent architecture. For example, we spawning 50 agents for a simple task, or continuing with the search once there's no more to be found. And here, what we are doing is shaping the agent behavior so these failure modes are overcome. So let's continue with the notebook. Here we have the node functions that we have already explained. Let's continue. Here we have the graph construction that we have explained also briefly. And let's look at an example of running this deep researcher. And specifically, let's look at my custom implementation. So let's go a little bit more, and here we have it. So what I wanted to do with my custom implementation is a sentiment analysis of an image that I provided as context. And I have tweaked a little bit the example by using different models. For example, for the research model, I use Grok. For the final report, I use GPT-5. And for the compression model, I use Anthropic. I did not allow clarification. And I wanted two parallel researchers that the supervisor could delegate up to 3 times, and that each researcher can make up to 5 tool calls. So as I just said, I provide an image as context, and I modify the prompt templates by adding this piece that, in essence, what it does is modifying the behavior. So if an image is provided, it incorporates the visual elements into the research question. So here we are importing the API keys. Here, what we are doing is using OpenAI model to describe the image, and the result of this response will be placed in the image content. Here we initialize our graph, we make the configuration as we have just said, and here we have our research request that we will be analyzing the sentiment about Taylor Swift's latest album, and the title and style is provided in the image that I have in data here. So here is the image. And next, what I do is simply running the graph. So here, what are we looking at is at the output of each of the nodes. And here we have the report, which includes a sentiment analysis analyzing social media as X about the latest album of Taylor Swift. So thank you so much. I hope that you have enjoyed this video, and bye-bye.